Okay. Hello. Uh, Today is April uh, 21, 2026. Today, I will show the analysis procedure and result of this given 10-story uh, frame using time history analysis. This is a moment resisting knee-rest frame structure which is subjected to the ground motion named as file named as 1.82. I will use this paper here. I will use this paper as a reference. I will use this paper as reference. Okay. For the making the for preparing the model and analysis, I will use this step. In step one, I will define material and then material properties, and then I will define frame section using AISC 360, and then I will draw the frame sections and assign 30 kilonewton per meter load as dead load on beam, and then I will make this load as gravity load and make it as non-linear, and then I will assign fixed support at base. After that, I will assign plastic hinges for all members, and then I will define time history function and then time history analysis load case. After that, I will analyze the frame, and I will show the analysis result like formation of plastic hinges, roof displacement, and reaction etc. So if I go to the SAP here, actually I have already run this model because it takes too much time to complete the analysis procedure. It almost takes 2 hours. So I have already analyzed the frame. So I will show the model creation procedure. At first, I have defined the material, like I have select here define and material properties. I have selected this and I have defined the material. After defining material, I have defined the section properties. So I have gone to section properties frame section, and from here I have just import new property, and I have used AISC 360 code. Here, I have selected this material properties using the reference here. In this reference paper, the beam sections are given as this for span 1 and 5, span 2, 4, and span 3. Here we can see that there are 5 span. Span 1, this is 2, this is 3, 4, and this is fifth span. So for this 5 span, beam section are given, and I have defined this beam section as beam. For knee element section, I have used this section. Actually, I have used this section. This is the final iteration result. So I have used this result for knee element section, and for beam stub section, I have used this frame section. Beam stub means this element, this part actually, this one, this one, this one, this one. And for the column also, the properties are given here. If we go to the design of beam, design of column, we'll find the cross section of the column given here. Here for column section, cross sections are given for 10-story building. So I have used this section for defining the column for different stories uh, here. So I have defined the frame section, and then I have drawn the frame section here accordingly. After defining the cross section, I have selected the beams. I have selected the beams like here, and then assign frame load, assign as frame load 30 kilonewton per meter, which is given in the assignment here. If we go to the assignment, sorry, 35 kilonewton per meter. So I have assigned 35 kilonewton per meter load in this beam section. So after defining the uh, 35 kilonewton per meter dead load, I have uh, gone to define and then load case, define load case, gravity, modify. I have defined this load as gravity load and then made it non-linear using P delta effect. So this is gone, and then I have selected the beam and I have selected all the beam and assigned plastic hinges at both ends, and I used M3 for defining the plastic hinges for beam, and for the knee element or bracing, I have used I have used uh, axial force axial force for defining the bracing, and for defining the column I have used PM2. By this I have defined all plastic hinges in all the sections of this frame, and then uh, I have defined go to define and then function. From here I have used time history function, and then I used this from file and I have selected uh, here from browse. I have selected my given 1.82 1.82 uh, ground motion. After that I have gone to define and use select load case, and I have defined this load case. I am history analysis one. If I go to modify here, we can see that I have selected time history, nonlinear, direct integration, P delta, acceleration type, load type acceleration, load name U1, function 1. I have defined already function 1, and scale factor is as the unit is kilonewton millimeter, so the scale is 9810, and for number of output time steps in my ground motion 1.82, there were 2999 uh, data. So number of output time step is this, and time step size is 0.01. For damping, I used uh, model result here. If I go here, we can see that for mode 1 time period was 6.128, and for second mode 5.54. So I have defined the period and uh, defined the damping 5% damping here, and recalculate coefficient accordingly. So after defining all of this, I have analyzed the frame. After analyzing, we get this. Now if we want to show the result, we can at first I will show the formation of plastic hinges. So I will go to display. I will go to display and show deformed shape. I will select low case time history analysis. Uh, if I select here 8 second, we can see that there are no uh, plastic hinge formed. If I see the result for 9 seconds and apply, we can see that first um, what is first plastic hinge formed here. It may not be fast. If we go to 8.7 second and apply, there is plastic hinge here, and 8.6 second, there are no plastic hinge. So we can tell that in 8.6 second up to 8.6 second, no plastic hinge is formed. So first plastic hinge formed after 8.6 second and at 8.7 second. So we can see here the plastic hinges. If we want to show If we go here, this point is 28, this joint is 26, this one is 24, and this joint is 3, this one is joint 50. So if we want to show the displacement here for roof for this joint, the joint 28, what we'll do, we'll go to display and then show plot function. We'll show again. I'll show uh, joint displacement or forces. Mm, Add plot function. I will show for 26, joint 26 or 28. Okay, 28 displacement x. Okay, so this one joint 28 one. I will delete this one, join 28, delete plot function. Okay, so join 28 one, add display. So this is the uh, displacement function for join 28 at different times. For time history function, we can see that maximum displacement occurs after 8.8 seconds. We can add uh, another displacement function like for different story, like we go to join displacement at plot function. If we 22 joint, okay, 22, mm, 24, okay, mm, 22 add display. We can show see that this almost these two function almost coincide. So uh, now if we want to show another function like forces, that is reaction, I'll go to here, and for first joint, for this joint, this support is support number 3. Support number 3 means joint 3. I'll go to reaction F1. Okay, done. Okay, joint 3 1, add display. So this function shows the reaction function with respect to time. We can see that after 8.8 seconds, maximum reaction is shown. Similarly, we can show other function if we want. Also we can show if we want, we can find shear force diagram and bending moment diagram for different time step. For uh, shear force diagram, we will select shear 2 2, and if we select time 0 and apply, we can show shear force diagram at 0 second. 0 second means it is for only for dead load, which I have assigned as 35 kilonewton per meter. But if we add 0.01 second, this result will be changed. And if we add 8.8 second, we will get maximum um, critical result where a fast plastic hinge is formed. And we can increase the time step and show the shear force diagram. If we want to show moment diagram, we will select moment 3 3, and we can show bending moment diagram for different time step. Also, we can show axial force diagram by selecting this uh, axial force. Okay. Hmm. We can also display this result as table. You can go to show table and base reaction like this, and what we want to show, we can show everything actually. For joint reaction, we can select like this. We can find the joint reaction. from this function. Okay. I think I have finished the presentation, and I will submit this very soon. Thank you very much.